Today's video is on the average atomic mass. For today's video, what we're going to be discussing is what makes up the atom and how we get the approximate mass of different elements. So first things first, we're going to go ahead and talk about the makeup of the atom. In this course, we're going to be focusing on just three subatomic particles: the proton, neutron, and the electron. The protons and the neutrons are in the nucleus or in the center of the atom, and along the outside of the atom we have the electrons. The protons have a positive charge for the atom, and the number of protons also determine what kind of an element that particular atom is. The neutrons are a no-charge particle of the atom, and we have the electrons as well, and they have a negative charge. Something that's going to be important for the mass of our atom is to note that protons and neutrons both have a large amount of mass, whereas the electrons have a very small, slight, negligible mass. So right here we have a atom. This is a carbon atom, and I want you to note that this atom has a total of 6 protons, 6 neutrons, and 6 electrons. If we were to go ahead and figure out the atomic mass of this atom, we would go ahead and add in the mass of the protons and the neutrons, and altogether we would get an atomic mass of 12. Here we have an example of multiple what are called isotopes of atom. We have a carbon-12 isotope, a carbon-13 isotope, and a carbon-14 isotope. I want you to take special note that each of these different isotopes has the same number of protons, but they have a different number of neutrons. So all of them are still carbon atoms, and they will still react as if they are carbon atoms. And the only difference is going to be in their weight. And their weight is going to be modified simply because each isotope of carbon has a different number of neutrons. So carbon-12 has 6 neutrons, carbon-13 has 7 neutrons, and carbon-14 has 8 neutrons. Now, what we're going to do here is we're going to go ahead and figure out how to solve for atomic mass. And an average atomic mass is going to end up being an average of all the different types of carbon that there are. So, first we're going to start with carbon-12, and carbon-12 is going to have 230 atoms. Carbon-13 will have 50 atoms, and carbon-14 is going to have 3 atoms. To figure out what the percent of each one is, we're going to go ahead and add up all of our atoms together. So we're going to have 230 plus 50 plus 3, which will give us a total of 283 atoms. We're then going to go ahead and take our number of atoms of each type, and we're going to divide it by 283. So carbon-12 has 230 divided by 283, and that makes up 81.27% of our sample. Carbon-13 is 50 atoms divided by that 283, and that's going to make up 17.67% of our sample. And carbon-14 is going to take up 1.06% of our sample because that's 3 divided by 283. Once we have our percents, what we'll go ahead and do is add up the amount of weight that they provide for our average atomic mass. So we'll do that by multiplying the mass of each isotope of carbon by its percent. So we'll take carbon-12 times 81.27%, and that's how much weight is provided by that isotope. Carbon-13, likewise, is going to be multiplied by 17.67%, and then carbon-14 will be multiplied by the 1.06%. as you can see here, we have all of our numbers. We can go ahead and now add them all up. And we see that the average atomic mass for this sample is going to be 12.1709. This problem is an example problem, a typical example problem that you might have for an atomic mass. What we're going to do is we're going to do the exact same process. And we're going to start by taking a look. We're going to gather our information, and we see that we have two forms of lithium. We have lithium-6 and lithium-7. Lithium-6 equals 7.3%, and lithium-7 equals 92.7%. So, for us to solve a simple problem like this, what we're going to need to do is multiply the 6.017 times 7.3%, and then we're going to multiply the 7.018 times the 92.7%, and then we're going to add those numbers together just like we did on the previous problem. And we see that we end up getting a number that's 6.9452%. Now, one quick note that I want you to take special care to notice is that when you are figuring out your average should be between your lowest number and your highest number. Our answer ends up being 6.9452, which is between the 6 number and the 7 number. So that's a good little double check that we can use to make sure that our answer makes sense to us. Because if we're averaging two numbers together, they should be in between those numbers and not higher or lower than the starting or ending numbers. Next, there's another type of problem here, and this is a type of problem where they give you an average atomic mass for two isotopes, and they want you to find where the percents are. And this type of problem is going to require us to use a little bit of algebra in order to figure it out. So, we're going to go ahead and take our different isotopes, and here we have indium-113 and indium-115, and all together they end up making an average atomic mass of 114.8. So, we know that indium-113 is going to have some percent, and we're going to have that as X% for right now. And that when we add that to the indium Y percent, it equals 114.8, because this also is some percent. Okay, so we just have variables in here for these two percents. Now, what we can also think of is that this X% and Y%, this makes up 100% of our sample. So 100% of our sample is made up of indium-113 and indium-115. Therefore, we can go ahead and make a brief equation for that. We know that X plus Y is going to equal 100%. Therefore, we can also say that Y is going to equal 100%, or 1 minus X. And once we do that, we now have the same variable in our equation. Notice we have an X as our only variable. If we only have one variable in our equation, that means that we can easily solve this equation. So what we can do is we can go ahead and plug in 1 minus X, and we'll go ahead and multiply our numbers through. So we're going to take 113, we'll multiply that times X, then take 115 and multiply that by 1 minus X, and all of that's going to equal 114.8. We'll end up getting these numbers here, where we'll have 113X plus 115 minus 115X, and that all equals 114.8. When we go ahead and solve for like terms, we'll end up getting negative 2x equals negative 0.2. Solving for x gives us 10%. Therefore, x is going to be 10%, and y will end up being 90%. And if we look back at our numbers, we see that the average atomic mass is much closer to 115 than it is 113. So we can go ahead and continue to use our logic to go ahead and help us check our answers just to make sure that they end up being correct. Average atomic mass is figured out this way for you on the periodic table. So, up here on this screen, we have the average atomic mass for uranium. And uranium has many different isotopes that it can be. We have went ahead and figured out what the average atomic mass for all those isotopes are, and for the most part, unless you're working with a particular sample, you're going to use the average atomic mass that's already been figured out for you, that is on the periodic table and is right here at the bottom number. This concludes the video for average atomic mass.